Let's explore some common properties of acids and bases. First, we'll put acids and bases in water and see what happens. So what happens if you have an acid, put like say hydrochloric acid put in water? Well, hydrochloric acid will dissociate to give you H plus ions and Cl minus ions. And because now there is more H plus ions in my solution, we will say that this solution has become more acidic because there is more H plus concentration. And this is the reason why we say that acids are H plus donors, because when they dissociate, they give you H plus ions. Now, these H plus ions can further combine with H2O to give you what we call hydronium ions. You get a H3O plus. And so when you put acids in water, you can either have H plus ions or you can all have them in the form of hydronium ions. Any of them will work. But that's what acids do in water. But now let's see what happens when you put a base in water. Like say you have sodium hydroxide. Well, they will dissociate to give you sodium ions and OH minus ions. Now, whenever you have more OH minus ions in a solution, we say that it is more basic. More OH minus concentration means more basic. And now you can see that OH minus ions, if they get H plus ions, they can form water. And that's why NaOH is, that's why bases love H plus ions. And that's why they say they are H plus ions acceptors, because H plus can combine with OH to give you water. So this is the reason why we say they are H plus acceptors. So what's the common thing between acids and bases? Well, they both dissociate to give you either H plus ions and OH minus ions. But the difference is these are H plus donors versus bases are H plus acceptors. But another common property for them is that because they will give you ions, these ions can conduct electricity. And therefore both acids and bases in water, so their acids and bases solutions, can always conduct electricity. Okay, but now we're going to have another question. How do we give a number to indicate whether how acidic or how basic a solution is? Well, that number is given by a new quantity called pH. Okay, what is pH exactly? You can think of pH as an indicator of H plus concentration in the solution. It has a formula which we will not discuss, but according to the formula, you know what happens? It turns out from the formula that if there is more H plus concentration, you will get less pH. I know this sounds very weird and you may be wondering why that happens. Well, that's how the formula is. And if you're wondering why the formula is that way, well, not worry too much about it. Okay, we have reasons for it, but let's try to familiarize ourselves with it. And I know it's a little weird, but we'll just familiarize ourselves. But remember, pH is a measure of how much H plus concentration we have. More the concentration, smaller is the value of pH. So let's take some examples. What would be the pH of pure water? Now, I would think that pure water shouldn't have any pH because pure water wouldn't have any H plus concentration, but that would be wrong. Turns out that pure water, H2O itself, can dissociate to give you H plus ions and OH minus ions. So there is some H plus concentration in pure water as well, and therefore pure water itself has some pH. If you put into the formula, which we will not discuss, it turns out that the pH of the pure water happens to be 7. And since pure water is neither acidic nor basic, we will say that 7 is a neutral solution. So any solution that has a pH of 7 or close to 7 is close to neutral. Now, I want you to think about what will be the pH of acidic solution. Do you think it will be 7, less than 7, or more than 7? I want you to pause and think about this. All right, let's see. We've already seen acids are H plus donors. So when you put acid in water, the H plus concentration increases. So my solution will now have more H plus concentration than before. Oh, therefore you'll have smaller pH. And therefore acids will have a pH less than 7. And so acidic solutions have a pH ranging from 0 to 7. If the pH is somewhere close to 0, like 0.5 or 1 or 2, that's very acidic. It means it's very high concentration of H plus ions. On the other hand, if the pH is close to maybe 6.5 or 6.7 or something like that, it's very low acidity. It's very close to being neutral. Makes sense, right? Finally, what about bases? What will be their pH? What is the exact opposite? pH are H plus ion acceptors. Bases are H plus acceptors. So when you put a base in water, they will accept H plus ions. So they will reduce the amount of H plus concentration in the solution. So H plus concentration in the solution reduces, pH will increase, and therefore the pH will be higher than 7. Turns out that the pH of most bases will be somewhere between 7 to 14. It'll usually not exceed 14 at all. Again, if you have a base whose pH is very close to 14, it's a very basic solution. If it's close to 7, it's not so basic solution. Okay, and let's take some examples now. Now that we have a pH, we can create a pH scale. You can see on this side, as you go lower in pH, more acidic. If you go higher in pH, more basic, and somewhere near 7, you have more neutral. And you have these examples, and you can just pause the video and you can go through these examples. You see, for example, blood has a pH of 7.4, so we say blood is pretty much neutral, slightly basic, but close to neutral. You can see, for example, grapes are very acidic because they have a pH value of 2.5, very low. Bleach is very basic because its pH value is 13.5, very close to 14. And so this is how, using a pH scale, we can understand how acidic or how basic something is.